Welcome to this tutorial on record arrays in NumPy. Record arrays are a powerful feature that allows you to work with structured data using a clean and intuitive syntax. They provide field access by name, making your code more readable and easier to maintain. Record arrays are NumPy arrays with structured data types that allow you to access fields by name. Think of them as enhanced structured arrays that provide a more convenient way to work with your data. You can access fields using attribute-style notation, which makes your code cleaner. They're similar to structured arrays, but with improved usability. Record arrays are built on top of structured array functionality, so you get all the performance benefits while enjoying a better developer experience. Let's see how to create a record array. First, you import NumPy as NP. Then, you define a data type using np.dtype. In this example, we create a dtype with 3 fields: name as a Unicode string of length 20, age as a 4-byte integer, and salary as an 8-byte float. Next, you create the record array using np.rec.array. You pass in a list of tuples, where each tuple represents one record. For instance, Alice is 30 years old with a salary of $75,000, and Bob is 25 with $65,000. Finally, you specify the dtype parameter to use the data type you defined earlier. Record arrays shine when it comes to accessing data. On the left, we have attribute access. You can simply use rec_r.name to get all the names, which returns Alice and Bob. Similarly, rec_r.age gives you the ages, 30 and 25. On the right, we have index access for specific records. You can access individual records using bracket notation. For example, rec_r_0 returns Alice, and rec_r_1 returns 65,000.0. This combination of attribute and index access makes working with your data incredibly flexible. Let's compare record arrays with structured arrays. The main difference is in how you access fields. With structured arrays, you must use bracket notation. For example, struct_r bracket "name" to access names, or struct_r bracket "age" for ages. With record arrays, you use the much cleaner attribute notation. Simply write rec_r.name or rec_r.age. This attribute-style access is more intuitive, easier to read, and less prone to typing errors. Record arrays offer several key advantages. First, they provide cleaner syntax. Attribute access is more intuitive and readable compared to bracket notation, making your code easier to understand. Second, they offer better autocomplete support. Integrated development environments can suggest field names as attributes, which speeds up development and reduces errors. Third, they maintain the same performance as structured arrays. There's no performance penalty for using record arrays over structured arrays, so you get convenience without sacrificing speed. You can easily convert between structured arrays and record arrays. To convert a structured array to a record array, use the view method. Write struct_r.view with np.recare as the parameter. To convert a record array back to a structured array, again, use the view method. Write rec_r.view with np.endarray as the parameter. This flexibility allows you to choose the most appropriate representation for your current task. Let's recap the key points. First, record arrays enable attribute-style field access, making your code cleaner and more readable. Second, they're built on structured arrays with cleaner syntax, giving you the best of both worlds. Third, they provide better integrated development environment support and improved code readability through autocomplete features. Fourth, you can easily convert between structured and record arrays using the view method, giving you flexibility in how you work with your data. Record arrays are an excellent choice when you need structured data with convenient access patterns.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.